Welcome back yet again. We're moving on to Chapter 6. In our previous chapter, we saw how the British empiricist movement brought many new ideas to our little history, philosophy of mind that we're covering here. And this includes a stronger endorsement of the empiricist view. Along with that, then theories of learning, including Locke's theory of ideas and associationism and all of that, but also a lot of monism as well, some materialism, some idealism. And ultimately, we see Hume and his skepticism was one of the consequences of these approaches, because with Hume and his skepticism, if you recall, he said that what we can know is what is given to the senses, no more and no less, and therefore, given how kind of impoverished these guys treat the senses actually don't provide us with very much information about the world. Again, that's like the translator problem, right? We don't know if the senses are telling us the truth about the outside world. And that's ultimately what leads to Hume and his skepticism. So, of course, somebody's going to want to offer a rebuttal. And this takes us back into continental Europe to the long-standing rationalist, dualist trends that were already in place. And we end up with Immanuel Kant. So that's the context here to understand where Kant is coming from, is that he is, in a sense, reacting against Hume's approach. There are several aspects of Hume's approach that Kant disagrees with. One is the idea of the mind as a passive recipient of sensations. Kant, as a rationalist, is going to argue for a more active mind, one that can actively structure our conscious experience as opposed to just passively following the laws of association. And so there's more room for free will here. But also the skepticism, right, that we can't know things like cause and effect, causality. Kant wants to say that the mind is active and it is structured in the sense that we have an innate structure to the mind. So he gives us what he calls his categories of thought, 12 innate categories of thought. Now, what do we mean by category? This is not the same kind of innate knowledge that Plato was talking about when he talked about the ethereal forms and all of that kind of stuff, where we know all of these different kinds of things. Kant has it narrowed down to a more finite set of categories, which represents the main universals that we need to talk about. So to use causality as one of our examples, Kant has a category for that. He would basically say that when we observe two billiard balls collide, as Hume would have used as his example, Hume says that we don't really know that the first causes the second. We only know that one thing moved and then another moved, and that there is no necessary connection between them. But for Kant, he says we have the innate capacity to recognize causal events when we see them. So therefore, because of our innate category for causality or cause and effect, then this is what enables us to perceive and recognize causal events and to discriminate causal events from non-causal events, which Thomas Reid has previously shown that we can do. So therefore, even though there's this room for empiricism in the sense that we have to observe something to know that it's happening, even Kant agrees there, Kant still says that some element or some aspect of our recognition occurs because of this innate knowledge, these innate categories. And this is the rationalist side of Kant here, that having this knowledge that comes before sensations and is necessary in order to interpret and make sense out of our sensations. I like the metaphor of a filter here, because this idea is, if you think about what does a filter do, a filter changes things, right? So if you put something through a filter, the filter removes the impurities and allows only the essence to come through. And that's really the gist of this, because what we're saying here is that this is just like back in Chapter 2 when we were talking about the particular versus the general. The particulars are the impurities. The general is the essence. Again, this is like what Aquinas referred to as essential qualities, or sometimes primary qualities. If we look at Locke and Galileo, the idea is that's what represents the identity. So here the idea is that for Kant, the innate categories allow us to filter the incoming sensory data, so that way we can remove the particulars of specific different causal events and still be able to recognize the essence of causality that is coming in through our sensory systems. But without that innate knowledge, we would not be able to recognize them as they are. But here, this Kant is now providing us with a justification to say we can trust our translator, because our translator is not just sensations and associations. Our translator is the innate categories, right? And that's trustworthy because it's innate and that's special for some reason. One example of how Kant makes it special is that he believes the brain is special because the brain is simultaneously part of the physical reality. It's a physical thing. It has certain properties, including causality applies to what's going on in the brain. But it's also the organ of consciousness. It gives rise to consciousness. And as such, the brain can structure consciousness as a function of its own properties. So consciousness itself becomes structured as a part of the properties of the brain. So the brain has kind of this special status, a dual status, as being both in the physical world and in the mental world at the same time. Our brain is kind of the translator. The categories arise from within the brain. So it's a more trustworthy translator. We can trust it. So he's going to try to justify realism here as opposed to the skeptical nominalism that Hume was arguing for. As mentioned, Kant was a dualist as part of the European tradition here, and so he uses different words, but it means the same as what we have previously called primary and secondary qualities. Kant calls the world as it is, things as they are, what we previously called primary qualities. He calls it the noumenal world. This is not the world of experience. This is just things unto themselves, as opposed to the phenomenal world, which is secondary, right? Things as they are experienced or perceived. These are our mental representations of things. So phenomenal means kind of ghost-like, and again, this is this holdover kind of thinking of the idea of the mind as more of a spiritual thing, as the noumenal world is very different from that. Something else that's important about the distinction between noumenal and phenomenal is the concept of meaning. I don't know if you've ever asked yourself the question, what is the meaning of the word meaning? What does it mean to have meaning? And that's a tricky one, and philosophers have made a big deal about this. And it boils down to the idea that ideas have meaning. Words can have meaning because words represent ideas. But objects themselves do not have meaning. I'll go with my trusty pen one more time. The pen as it is doesn't have meaning. It is what it is. And it doesn't mean anything. The pen. But on the other hand, my idea of the pen has meaning in the sense that it refers to something outside of itself, right? And that's the meaning of meaning, is to refer to something outside of yourself. This is to say it has extension, right? And so in this case, my idea refers to the real thing. The real thing doesn't refer to anything, it just is. But the idea refers to the real thing. And that's the nature of the phenomenal world. The phenomenal world is a set of representations or references to an external noumenal world, right? Although again, they don't exactly match each other, as the nature of primary and secondary qualities had revealed to us before. We can also create this little 4 steps here as a way of outlining Kant's perceptual theory. So again, we've got objects in the world. We're going to start with them. If you go back to that diagram in Chapter 5, having the distal stimulus, this is kind of the same thing here. This would be Kant's noumenal world, step number 1. But then we receive sensations, right? And so these are, again, what we previously called simple ideas in John Locke's theory, or secondary qualities. These are meaningless, right? Meaning has to come in somewhere. We have to apply meaning. Meaning has to come only in the phenomenal world. Where does meaning come from? That's in our mysterious step number 3. To get from sensation to perception, there has to be an internal structuring process that applies meaning to meaningless sensory inputs. The output of this process gives us a meaningful perception, that is, our mental representation of an object like the pen, and correspondingly our knowledge of the universals like cause and effect. So the innate categories, that's what's going on in step 3, right? Kant's filtering process, where the innate categories apply meaning to meaningless sensory data. So in a sense, Kant agrees with Hume about one little thing. The sensations that are coming in from the outside world, they're kind of meaningless, right? And we don't really know what they mean. we need a translator, but a translator we can trust. And so therefore, instead of using this passive bottom-up associationistic process that Hume was talking about, Kant invokes this more active structuring by the innate categories. So in Chapter 5, we referred to that associationism as bottom-up processing, right? This is its opposite. And you may know this is top-down processing, right? Knowledge that is already in the mind, that exists a priori, that is before a sensory experience, is used to help interpret sensory experience and to apply meaning to it. That's top-down processing, and that's exactly what Kant contributes to psychology. Of course, elements of that arise from, say, Plato's theory, reminiscence theory and stuff like that, but Kant makes it a little more obvious about making perception an active, structuring, or interpretive process. Kant also tackled the problem of how do we perceive a three-dimensional world. I'm labeling it here as space perception, the problem of how do we perceive three-dimensional spaces. Something Berkeley tackled, right, when he talked about, it's not real, it's just an idea based on depth cues. Kant's solution is to say that we have the innate category for the three-dimensional world, right? So, our presumption is that the noumenal world is three-dimensional, so it's a part of step number 1, but it's not a property of step number 2. The sensations are not three-dimensional. But invoking in step 3 this structuring process from the categories of mind, we add meaning. In this sense, we interpret the input in terms of the third dimension. And then, of course, we end up in step 4, where we have a meaningful perception of a three-dimensional world, representing the external three-dimensional world. This idea of top-down processing becomes very popular and begins to take off, and it begins to influence many other theories of knowledge in the 1800s, especially amongst the Germans. Kant, being in Germany, highly influential German philosopher, kind of considered almost the most important German philosopher. And so some of these guys who in their time were not really considered to be psychologists, from our perspective in 2018, at the time of this recording, they kind of sound like psychologists, but guys like Hermann Lotz here consider themselves to be essentially physiologists, right? They were studying human physiology, including the nerves. Now, they were neuroscientists, too, of the sort, but because of the limitations of the time, they were doing things like reaction time studies. So they were studying human behavior and human movement, human responses to stimuli. They just saw it as a neuroscience approach. And this is where Lotz comes in, because he borrows from Immanuel Kant the concept of top-down processing, but he eliminates the blank slate side, he eliminates the innate categories side of things here. So that purely rationalist type of innate knowledge thing he does away with. So it's more empirical in the sense that could invoke a blank slate idea. What is he talking about here? He's asking, again, this question of how do we perceive a three-dimensional world? And again, the problem is that the eyes are limited. The eyes can only give us two-dimensional images. So where does the knowledge of the third dimension come from? Lotz's answer is it comes from what he calls a local sign. That means it's a local sign, means a sign is like a signpost, which is a location marker, right? Which we can label it as an address. So it's a location on the body. And so all of our touch sensations, whenever I put my hand on something and I touch it, that activates receptors in my skin on my body, which I can localize because I know where on my body it occurs. So each sensory point that I touch is a local sign, right? A local signpost, a local address or location that tells me where this object is that I'm touching. And so it's like a map, right? I've got in my brain something like a map of the body, and whenever it activates an address on that map that the brain can localize. But what's important about touch here is that Lotz is essentially saying that touch has a privileged access to the third dimension, because when I hold an object in my hand, let me pick something that's a little more three-dimensional than my pen. I've got this book here. So when I hold it in my hand, it's got a height, it's got a width, and it also has a depth, right? So it's got 3 dimensions, and when I wrap my hand around it, I can experience with my hand all three dimensions at the same time. So touch seems to be able to access the third dimension directly, really, without, unlike vision, which only gets two-dimensional images. Likewise, of course, I can move my hands in all directions. I can move them side to side, up and down, and back and forth. So through movement, I have access to the third dimension. So according to Lotz, our knowledge of the third dimension doesn't require innate categories of thought. It requires movement and touch. But of course, when we are infants and we're learning to perceive the world, the idea is, while our visual inputs may be more flat and two-dimensional, and we look at things and touch them typically at the same time. So an infant will hold a toy in his or her hand, manipulating the toy and experiencing through touch its three-dimensional size and shape while looking at it. And over time, what's going to happen is that the touch experiences help to inform the visual experience so that the eyes learn how to see in 3D, but they only learn this by simultaneously looking and touching through hand-eye coordination, right? So this is basically one sensory system helping out another sensory system and doesn't require innate knowledge. So this is much more empiricist. We don't need innate knowledge. We can be a blank slate. Now, I says it has this rationalist concept there because of the top-down processing, right? So this is top-down processing. This is knowledge coming in from one sensory system down onto the visual system to help interpret that visual input, right? So the touch, this kind of structuring internal interpretive process is top-down active processing. That's what makes this kind of a hybrid, but a little more empiricist than what Kant was talking about. In fact, this is represented more broadly as what we'll call the haptic theory of space perception. Haptics means all of our perception of the world that comes through movement and active touch, exploring the world, not just with our hands, but even as we walk around, we explore the world. Even Berkeley had entertained this possibility, but Berkeley had considered it to be nothing but an association, that there's nothing inherently three-dimensional about my experience of touch, and I just associate visual experiences with haptic experiences, and this just leads to, again, more ideas of depth, but not necessarily something that's real. We don't need to linger over that too much here. I want to get into Helmholtz, who represents sort of the modern foundation of perceptual theory, and you will encounter Helmholtzian ideas in modern mainstream cognitive and perceptual psychology. So as we're showing here, he represents a fusion of some of the ideas coming from Kant and Berkeley and Lotz about, number one, of having top-down active processing, and from Berkeley and Lotz having associations and having one sensory system influencing another, and also the blank slate stuff a little bit here. Helmholtz is not going to be a big advocate of innate knowledge. Now, Helmholtz agrees with the general problem here that sensations themselves are meaningless. They don't necessarily tell us everything that we know or need to know about the outside world. Again, the outside world is meaningless stuff. Meaning is applied internally in our own minds. So as we're saying here, they represent raw elements of experience. And of course, the idea of raw means they need to be cooked. Something has to be done to them. We have to apply meaning to them. Where does meaning come from? Well, not from the innate categories, but rather from, according to Helmholtz, prior experience. So now he can be an empiricist, right? He can be a blank slate. Say, it's not innate knowledge, it's prior experience. And Helmholtz has a name for his process here. He calls it unconscious inference. So the unconscious part is somewhat self-explanatory. The idea is that we simply are not aware of this process when it occurs. We receive sensations, and then we go through this process of inference to figure out what's going on with these sensations and what is it that I'm perceiving, and this generates conscious perception, and that's what I'm aware of. That's what I'm conscious of, is my perception. But the processes that get me from sensation to perception happen below the level of conscious experience, and that's why it's unconscious, this process. Inference is the suggestion that what I'm doing is I'm essentially trying to come up with a best possible interpretation or guess, and making an educated guess about the nature of the sensations that are coming in to my eyes or to my ears. Consider this image here. It's a photograph of a perspective of the photographer standing on railroad tracks. Technically, as a two-dimensional photograph, this is an ambiguous image, right? Ambiguous meaning there's two possible interpretations. One interpretation could be the three-dimensional one, right, where you see the rails as extending away. If you follow my cursor, the rails are extending away in the distance, and they are parallel to each other as they extend away in the distance. But that's a three-dimensional interpretation. A two-dimensional interpretation would say that these are not receding in the distance. They are just merely going up and coming together at a point in the middle of the image. So, and of course, all of the other things, the railroad ties themselves, rather than being all equally sized and spaced and receding away in the distance, they just get smaller and smaller and shorter as they shrink to the middle of the screen. So one of those interpretations may be more correct than the other, and the question is, how do we know which one should be the right interpretation? This is equivalent not just to explain how we look at photographs, but if you were actually here, standing on the tracks, looking down the tracks, this is equivalent to what your eyes would receive, this two-dimensional image. And Helmholtz says that we have to make an interpretation. And how are we going to know which interpretation? Experience, right? We may have never stood in this place before, but we may have stood in other places with similar kinds of patterns, similar depth cues, right? Like the linear perspective and the texture gradients and the other things that are happening here. The previous time that I have seen those, I knew that it was distance and depth. So I'm going to say this current scene, informed by my prior experience, will be interpreted as a three-dimensional scene, and the rails are in fact parallel and receding away in the distance toward the horizon. But we could ask some other questions. First, let's first take a look at how we're going to apply that four-step perceptual theory to Helmholtz's theory here. So again, we've got the railroad tracks to be perceived in the world, but the sensations that we receive are meaningless in the sense that they are ambiguous and require interpretation. So step 3 is going to be our process of unconscious inference, right? Top-down processing here. Prior knowledge is used to apply meaning to current sensations. We're going to have to break it out a little bit because there's two steps that have to happen here. The first thing that has to happen is that I have to find which of my prior experiences that are relevant to this current one, because I've got, of course, all kinds of prior experiences that I might draw upon, so I have to narrow things down to only those that are really relevant. And then once I have identified them, that's when they will be used to interpret, to figure out what's going on right now. The output of this unconscious process gives us conscious perception in step 4. One of the other implications of this kind of perceptual theory is that perception may not always be correct, right? If perception is really seen as a form of inference or judgment or guesswork, it might occasionally make the wrong guess, right? What if the experiences that we're looking at, that we're drawing upon, are the wrong prior experiences? We might make a mistake and access the wrong prior experiences, in which case we might end up making the wrong judgment. Or sometimes we may not have enough sufficient prior experiences to be able to make a good judgment. So again, we may end up making a mistake until we learn otherwise. So there are possibilities here. And of course, anytime we see any evidence of experience altering the way we perceive the world, that could be evidence essentially for Helmholtzian theory. So there are very rare cases here of people who can be born with visual defects of various sorts, usually cataracts, which can, if they're bad enough, be a serious visual problem, essentially blindness. But cataracts can be corrected. And in some parts of the world, children are born with cataracts and they don't end up getting corrected until they're much older, maybe 8, 9, 10 years old in some cases. And what we learn is that these people cannot start just seeing the world, right? They have to learn to see, right? It's not like they just flip the switch, their eyes come on and they just see the way anyone else sees. It takes time. Of course, newborns take time. We know that it's really almost a year before infant vision is on par with adult level vision. Suggest experience is pretty important for learning how to see. Sensory deprivation studies, really popular in the middle of the 20th century with cats and rats and various other animals kept in these in particular environments that control the nature of their visual experiences. For kittens, a lot of the research, I think it might have a picture here. No, I don't have a picture, sorry. There are examples of kittens raised in these rooms where there are only black and white vertical stripes painted on the walls, small little boxes and drums they're kept in. And this restricts the nature of their visual experience, but then it restricts the nature of their visual abilities later, since this is all they have ever seen from the moment they were old enough to open their eyes. That's all they've seen. And it changes the way their brains develop, and it changes what they're capable of actually seeing, and therefore of what they're able to do. Research on prism adaptation has a similar effect here. So let me go to this next slide to explain what prism adaptation is about. Here on the left is a drawing of what prisms do. So here's a person's head seen from top down. That's their nose. The prism, placed on goggles in front of their eyes, it bends the light. So an object that's located at point A in the world, which is directly in front of this person, will actually appear as if it shifted to the right a few degrees at location B, because of the way the prism bending the light causes the light ray as it enters the eye to come from another direction. And that direction would be in the location of point B. So if you were to put the prism goggles onto a subject in your study and hold an object up in front of their face and ask them to just reach out for it, they're going to aim for where it appears to be, which is location B. And they're going to miss. As you see in this first picture, the man has aimed for the white circle and he has missed it to the right by a few degrees. This is what happens at the beginning of your adaptation period. Right? But after about 10 attempts to reach for the target, our participant now reaches accurately for the target. He has adapted. This is what prism adaptation is, and it takes time. It doesn't occur, it's not a conscious decision where you reach one time, you miss, and you say, oh, I have to correct my reaches now that I'm wearing these weird goggles that the experimenter has put on me, and I have to shift my aiming over a little bit. At least not a lot. It takes them 10 or 12 times to figure out exactly how to shift their aiming. But if this was purely just a conscious decision on the part of the participant here, we would not find what occurs when you take the goggles off. So now the man has the goggles removed, and you would think, oh, if it's just a conscious decision, I'm going to go back to my previous normal functioning and aim for the target normally, but he doesn't. Now, as he tries to aim for the target, he misses and ends up on the left and has to readapt back to his normal functioning state. So what this is showing is that prism adaptation is not just conscious choices to aim in different directions, but rather it's a recalibration based on learning of the mapping between visual inputs and hand positions, right? And this kind of learning and perceptual learning, could be seen as evidence of an unconscious calibration process, inferential process. Something else that's also crucial, what we call this is called the after effect, but it's also, to go back to the previous slide, called negative after effect because the mistake is on the opposite side than the first mistake. But something else that occurs in these prism studies is that if you get a person who is fully adapted to the prism and you take the goggles off, but then you put a blindfold on them right away, and what's going to happen is that, of course, they have nothing to look at, nothing to aim for. But if you say just point straight ahead of your nose, right? So hold your finger out in front of your nose as if you're pointing straight ahead. And even in this case, they don't point straight ahead. They point off to their left. Even though you would think that having your arm coming across your body and pulling to the left would be something that should not feel like straight ahead, it does feel like straight ahead to these participants, suggesting again that there's nothing necessarily innately objective about feeling the alignment of our heads and necks and shoulders and arms, but rather it's all based on what we learn. And prisms cause us to relearn or to recalibrate these systems. Another example where experience seems to affect perception is in the case of illusions, which, of course, because illusions involve what we might call as wrong perceptions, then this means that, again, sometimes perception can be in error, evidence that it's really a form of inferential judgmental process that may occasionally go wrong. The Mueller-Lyer illusion is shown here on the left. These two vertical lines, the task for a participant is to judge which of the two is longer or whether they are the same length. Now, all of us as sophisticated psychologists know that those two vertical lines are the same length, but the illusion is that the one on the left with the inverted arrowheads looks to be longer. Why does it look to be longer? Well, one explanation based on experience is that these look like corners, right? The one on the left looks like the interior corner of a room, where this would be where the walls meet, and this is down here on the floor, and that's the ceiling. So it looks like this image over here on the right. That looks like something that's concave, it's receding away from you. But this shape looks like the outside corner of a building, right? So again, this is where the walls meet, and this is the roof, and this is the ground, right? And this is like this image here on the left here. So that looks like something that is convex, that's sticking out at you. And so if one of these things is kind of sticking out at you and the other is receding away, the distances might be different, right? This one might be far and this one might be near. So if you have two things, one is far and one is near, but they both present the same image to your eye, one of them must be bigger. It's the far one, right? This is why you can do those things where you can use your finger to cover somebody's head, and the old joke, I'm crushing your head, right? That's because it's not because your hand is really bigger than somebody's head, it's because of the distance difference, right? So the idea is that based on our experiences in observing buildings with these particular structures, with right angles that form corners like this, that this Mueller-Lyer figure activates those prior experiences with those kinds of buildings and objects. And this then activates a process that causes us to interpret this as a large faraway object and a smaller near object, which is wrong according to the way the stimulus is designed. The lines are the same length and you're supposed to be able to see that, but you just can't. It's supposed to be evidence that experience is infiltrating the perceptual process and causing us to see these lines a certain way, forcing one interpretation over the other. Some evidence to support this comes from studies of certain primitive people who live in places where they don't build rectangular houses, right? So they don't experience right angles. Right angles don't really occur in nature, and they seem to not be susceptible to this illusion. That is, they seem to look at the two lines and suggest they are the same length. They're not prone to it. Although that's a problematic research area, because just read a few recent papers that showed that fish can see the illusion, right? They train fish to respond to different lengths of lines, right? They choose to prefer a longer line to. They go up and point their nose at a long line. They will get rewarded with a treat. And so these fish can be trained up to always, when selecting between two lines, to always select the longer of two lines. And then they put the arrowheads on the lines, make the two lines the same. And again, the idea is that the fish should not prefer it, but they do. They prefer the one that is subjectively, illusorily longer. So how come fish are subject to the illusion? I think maybe there might be some cultural problems with some of those studies of primitive people who apparently are not immune to the illusion, or are immune to the illusion, that maybe we cannot interpret it the way we think. But moving on, there are some problems with Helmholtzian theory. How does learning occur? All right, so when we talk about this idea of having prior experience to draw from, but what happens when you don't have prior experience to draw from? You have to get started somehow, right? And that's not really part of this theory. There's no explanation of it in this theory. How do you kind of get kick-started off from the ground up when you don't have prior experiences to work with and to draw from? And that's a problem. You don't have an explanation for it. Essentially, that's bottom-up processing. Is I don't have any experiences to draw from. I have to get going from the ground up. This theory somehow presumes that we must begin with bottom-up processing, but at some point in our lives switch over to top-down processing. Why is that even an issue, though, right? If we're able to start figuring out how to perceive the world from a bottom-up approach in infancy, why do we need to switch to start using top-down processing later on? That's not clear. Related is this issue of infinite regress. So if we go back to this example of the railroad track picture, you're standing there and you've got two possible interpretations, the 2D versus the 3D. and I ask myself, which of these two is the right interpretation? Well, I need prior experience. And now I say, let's talk about that prior experience. If Helmholtz was standing there next to me, I would say, Herman, how am I able to use this, or to recognize this world as three-dimensional? And his answer would be, you have prior experience with something similar. So I would say to him, all right, let's talk about that one prior experience. At that point, how did I recognize the world as a three-dimensional place? And he would say, well, even before that, you also had the other prior experience. And then I would say, oh, okay, well, then let's talk about that prior experience. How did I know it then? And again, he says, well, something else, some other prior experience to that. And on we go. So the explanation for how perception is ever able to recognize anything is always really just pushed into the past. It's always just explaining it away by saying, well, at some point in the past you figured it out. So now that you already know it, you can figure it out with your current sensory experiences. But again, it's never explained how we figured it out the first time, which actually takes us back to that first problem. How do we get going from the ground up? There's no explanation to this. So we call this infinite regress because we're just regressing backwards into the past to explain how perception works. Supposedly infinitely, but of course we can't really go back infinitely. At some point we hit this brick wall, which is being born a blank slate with no experiences before then. What do we do then? The third problem, the problem of constancy. And that's not really a name of a problem for Helmholtzian theory, but it's a name of a problem that all perceptual theories have to explain. And there may be some issues with how Helmholtzian theory addresses it. What is the problem of constancy? Let's go to this one. There are different kinds of constancy, so this one is called the problem of shape constancy. Here we see three doors. I can ask you, what shape are the doors? And you should hopefully say that they are all rectangles. And you would be correct. These doors are rectangles. But in the image, they're not all rectangles. The one on the left is, but the other two are trapezoids. One is a little bit more of a compressed trapezoid than the other, but they're trapezoids in the image. So the idea here is that when we see an object in real life, such as a door at an angle, we don't see it as changing shape when the door opens, right? We see it as having a constant shape. It maintains its constant rectangular shape, despite the fact that in the images that our eyes receive, it changes shape as it swings open. It becomes a rectangle, and then it becomes a trapezoid. So in the world, of course, it's constant, and in our perception of it, it's constant. But in the sensations, the images, it's not constant. So how do we explain constancy, right? How do I explain that my perception remains constant despite the ever-changing nature of sensations? And, well, again, of course, Helmholtz is going to invoke prior experiences. But again, if we realize, we go back to one of the slides where step 3A is. Step 3A is that I have to narrow down all of my prior experiences to just the right ones that are relevant to this particular experience, which means I need to narrow things down to rectangles, right? But how do I know I need to narrow it down to rectangles? Because I don't even know yet that I'm perceiving a rectangle, that I'm looking at a rectangle. I only know that when I get to step 4, and I'm still in step 3A. So how am I able to actually narrow down my experiences to just the right experiences without already having some advanced knowledge of what I'm looking at? Because knowing what I'm looking at is going to be relevant to knowing which experiences are relevant, right? So in a sense, in order for this theory to work, step 3A has to have some kind of privileged access to knowing which experiences are the best experiences to use. That is, which ones are the relevant experiences to use. And I only know what's relevant if I know what I'm dealing with. So there's a circular problem here, right? There's something like circular logic. For this kind of system to work, it has to know something it's not allowed to know, right? It's giving itself the answer in advance. And that's a problem, right? And so how the Helmholtzian theory addresses the problems of constancy and recognition may have some logical inconsistencies. And that is the end of chapter 6.